Lesson 4, so part 1 of dividing radicals. In previous work, we talked about in that definition state that square root of a over b is the same thing as root a over root b, which means, just if you want some numbers for context, if I told you to square root 1/4, you could go root 1 over root 4. That's how you do it. Okay, so the radical goes top and bottom. Okay, so we can use this rule to divide radicals in the form of, so there's a coefficient. Okay. So to divide radicals with the index must be the same, so it has the same rule there as multiplication. Okay, and then instead of multiply, it's obviously divide the radicand. So it does look weird, but it's kind of like I'm going to simplify 15 and 10. I'm going to simplify 48 and 6. Okay, just treat them as kind of, I don't want to say separate, but like terms in the same way. Okay, so if we do that, let's go and look at this first set of examples, just very straightforward. What is root 30 divided by root 6? Root 5. Make sure it's the root's still there. Okay, the root doesn't cancel. No, it does not have to be included. Okay. So now this one, you're going to go 8 divided by 2 for the 4, 21 divided by 3 for the 7, and then don't forget your cube root, as you guys usually remind me myself. Okay. So that's just nice, just simple division there. So like we talked about part C, we will keep the fraction, okay, because 15 over 10 isn't even, so it's going to be 3 over 2. Right? 15 over 10 reduces to 3 over 2. 40 over 6 is, what's that, root 8? Root 8. And that goes on top, right, because it's like 8 over 1. We don't need the 1. And we can break the 8 down, right? So this is where we have to go a little extra step. 8's 4 times 2. So that 4 comes out and hits there. And so you can kind of see what happens. It's kind of nice. This 4 becomes a 2, right? So essentially cancels that 2. But we'll just go ahead and do it. 3 times 2 is over 2. And then root 2. I know it's a lot of 2's there. Let's try to sort this out for you. So we broke the 8 down to 4 times 2. The 4 comes out as a 2. That's what's right there. The 2 was left. 3 times 2 is 6. Over 2 is 3. So you can see that's just going to be 3 root 2. Will be the simplified answer there. Okay, questions there? I know there's a lot of 2's. We just got front and back notes today. It's going to be very quick, okay? You can get after it and get some work done. But with that, you can ask questions. What's that? That's right. Okay, so now I threw variables at you. Just want to let you know, if you're saying, will variables be under test? It is part of the standard. It does say you have to be able to work with radicals of variables. All the variables do is really what? Because you don't know what those numbers are, so it doesn't make the numbers. It kind of makes it easier because if you have a variable in there, you have to do the rule or do the law with that specific thing. Because if you don't, then you'll just get it wrong because you have the wrong setup. Okay? But you're right, it's not going to get hard. All I know here is the a's are going to cancel. Right? That's all that's going to happen here. So this is going to be root b over 3. The a's cancel. The b's still on top. 4 over 12 is 1 over 3. You can also write that as 1/3 b if you want. You don't have to write root b over 3. Yeah, because the 4/12 is 1/3. So maybe, Joel, if you want to write it, you can write it this way. This might make more sense to you. 4 over 12 is 1/3, and then we have root b. You can still write it like that. That's still right. Okay. Awesome. We go to the second section. Feeling comfortable? Division is not too bad. Like I said, I really think division and multiplication is actually easier than addition and subtraction, just because you have to break down, try to get them to match. It's like kind of like with fractions, right? Fractions, multiplication, division is easier, just straight across. Addition and subtraction, you get a common denominator. Okay, so this one, 54 and 8 don't work, right? So, but we can break 54 and 8 down. So let's do that. 4 times 2, 9 times 6. 9 comes out as a 3. 4 comes out as a 2. So we'll have 12 root 6 over 6 root 2. Well, that's cool. So look what happens now. 2 root 3. Or we thought we couldn't do anything, then we simplified, now it's really nice. 2 root 3. 12 divided by 6, root 6 divided by root 2. Go ahead and try B. Try B. See if you can get that there. What did 126 break down to? 9 and 14. Okay. And how about 112? 16 and 7. We like that because 14 and 7 will be left, so that's good. So 9 comes out as a 3, so we have a 24 over root, or 24 root 14 over 4 root 7, 6 root 2. Yep. Cubic, a little bit harder here. So 162, just see, does 27 go into that? Yeah, how many times? 6, so 27 times 6. 128 is the 64, so that's 64 times 2. Okay. 27 comes out as a 3, so 3 times the 10. 30 cube root 6, good. 64 comes out as a 4. Yeah, 80, oops, my part, the 0 there, 30. Yeah, 80 root 2, or cube root 2. And we get 30 over 80, so that's 3/8. So you can just write 3 over 8 if you want. And then you can put the 6 over 2, that's 3. So cube root 3 can go on the side or on the top. Doesn't really matter. Either's fine. Okay, section 2 done. Now for example 3, they just want us to break all these down and simplify. You got the root 6 in the bottom, so I'd look for 6's. Okay? So like this one, that's 4 times 6. This one is 6 times 8. That doesn't really help me too much. 16 times 3 is the biggest it breaks down to, though. And then 108, that's the 36 times 3, I believe. So if I simplify all those tops, I'm going to be at 2 root 6 plus 4 root 3 minus 6 root 3. Can I simplify more from there? What can I simplify? Well, before the divide, just the top. Yeah, we can combine these, right? Yeah, let's go ahead and do that. 2 root 6 minus 2 root 3, right? It's all over the root 6. So what do you do with fractions in this form? How does that root 6 affect the top? So here's this, and I said this on purpose, and Lucas, I'm not going to hold you to this, but Lucas said you can cancel it. You can, but this has to go to both. You can't just, and people do this all the time, they'll go, cool, and then leave it, done. It doesn't work that way. Because it's broken up to 2, right? Like, for example, just a basic example. If I said 2 plus 3 over 5, that's really 2 over 5 plus 3 over 5. Right? It's broken up. The denominator hits both items. So don't do that little quick cancel and call it good. Understand? Okay? So you can, however, you can cancel it, just so we have to hit this one as well. So this is 2, so that's right. That's a 2. This one's going to be what? Negative 2 over root 2. You see that? Root 3 over root 6. It's 1/2, so the root's on the bottom. We're going to talk about what to do with those, I think, next time. I think we rationalized for the last lesson. Let me double check here. Nope, we're going to rationalize a little bit today. We're going to do the conjugate rationalizing next class, which will be tough. Okay. Anything else? All right. All right, just a second here. It tells you right here what rationalizing is, but rationalizing is simply we don't want radicals on the bottom. So you have radical on the bottom, and it says rationalize. That means you're going to get that on the top. The way we do that is we use the thing that we know, what root 5 times root 5 is what? Root 25, which is 5, right? Getting rid of a radical. You can do anything you want to a fraction as long as you do it at the top and the bottom. So what we do is we say, okay, I don't want root 13, so I'm going to multiply root 13 at top and bottom, and that's going to bump it up. So we don't have a radical on the bottom. Okay? So that's what rationalizing is. Any questions on the goal with rationalizing? Okay, so let's go ahead and do a couple here. So root 13, this one's a pretty basic one. I'll just stay with this, it's kind of nice. Root 13, top and bottom. This becomes just 13. The root 13 is now on top. I rationalized. Okay. Okay, so again, these are multiplied to get the whole number. Have to do the top as well. There it is. Now, question. If you put 1 divided by root 13 in your calculator and you put root 13 divided by 13 in your calculator, would you get the same value? Yes, we're simplifying, right? We're not evaluating, we're not solving, we're simplifying. So this is this simplified. So they are the same value. So again, you can check your work on these easily. Okay, so this one, root 2 times root 2. It's root 10 over 2. That's the rationalized value. Okay. Now the negative is not super important for the second one. I'll slow down here, I'll let you catch up. But the negative is not super important in terms of I don't need to go times a negative root 6. I can just do root 6. Because we care about the radical, the negative is not a problem. Root 6 times root 6 would be negative 6, yes. The negative stays there. Good, Parker. Okay, root 6, root 6. So I get root 12, which we know can break down. We'll do that in a second, over negative 6. So he's right. See, the negative's still there. Root 6 and root 6 is the 6 with the negative. All right. So we know it's going to be 4 times 3. So it's going to be 2 root 3 over negative 6. If we fully simplify that all the way, it's going to be root 3 over negative 3. 2 over 6 is 1/3. Okay. Yeah, 2 root 3 over negative 6. 2 root 3 is the root 12 broken down. Okay, go ahead and try D. See if you can get D and simplify it on your own here. I'll pause the video. Here, so we should have got, okay, so we can go root 3, root 60 over 3. Root 60 breaks down to 4 times 15. So you should get 2 root 15 over 3. And that's as far as you can go. Okay, we got one more set and then a little bit of a challenge one I'll let you guys try here at the end. Just a, not really a challenge one, just a little bit harder. Okay, so simplify this one. So let's go root 7. We don't really care about the 3, okay? Because the 3 is not a radical. So we'll have 7 root 7. And what's going to happen on the bottom here? 21, right? 3, and then that's a 7. So your final answer would be root 7 over 3. Because 7 over 21 is 1/3. Okay, so we did here is, we did the root 7 still to get rid of it. Root 7 times root 7 is 7. 7 times 3 is 21. This stayed the same the whole time. 21 and 7 reduced to 1/3. So remember, that's root 18 and root 5. Okay, so we can do this now, 9 times 2. We can make the top 3 root 2 over root 5. Just make your numbers smaller. If not, you're going to be dealing with 90 instead of 18. It's up to you. But you don't have to now. Root 5. So you're done now. It's 3 root 10 over 5. I'll do this one. I'm going to have you guys try this one with your table partner for example 6. Okay. All right, so 3 root 12, I just see these already can be broken down, so I'm going to just gravitate to doing that first. So 4 times 3, 36 times 2. The top ends up being 6 root 3. The bottom ends up being 6 root 2. So my 6's cancel. Let's see here. 6. Yep, we're good. Okay, so that comes out. We go root 2 times root 2. We get root 6 over 2. And then that's our answer. Okay, as you catch up and finish those 3, go ahead and try this one with your table partner. When you have an answer, we'll put all the answers up on the board, okay? Just see how we do. So a lot of you guys got to the right answer, had a couple little hiccups. A couple of you guys tried to divide just one of them. Remember, it divides to both. Okay, so I'm going to go ahead and do the rationalized denominator first one. If you want to see this one, we can talk about it later, but we'll just finish up with this being done here. So we go root 2 to both. They distribute. You can break them down first if you want. It doesn't matter. I think most of you didn't, so I'm not going to. So that gives me 36. That gives me 24 on the top, and now 2 on the bottom. Oh, well, square root of 36, that's nice. Square root of 36 is 6. 6 times 3 is 18. 24 breaks down to 4 times 6. So that's 2 root 6. And this is where everybody messed up, probably about 6 of you. So the 2 goes here and here. Divides to both terms. So 18 divided by 2 is 9. The 2's essentially cancel here. 9 minus root 6. That's your solution there. Okay. So what you could do first, you could have done root 2 to 18. So I'll just start B. If you start B, it'd be 3 root 9, because 18 divided by 2, 12 divided by 2, root 6. A little bit faster, yeah? Because what's the square root of 9? 3 times 3, and you're back to the answer already. So that case is a little bit faster. Okay, all right, we are done.